All right, class 7 of the A Priori section of the Philosophy Year 1 101 Backbone course. I always forget to turn my phone off first. Are you teaching right now? Yes. How about yes? Or maybe I'll just silence myself and they'll get the message. I'm so sorry. Here we go. I got to remember to do that every time. Okay. So we're in the year one backbone course. We're doing the a priori section, which is section 5 of the 8 sections. We're more than halfway through. We were sailing through it until we decided just to do it on Tuesdays instead of Tuesday, Thursday, Friday, so that we can do philosophy of mind and philosophy of religion on Thursday and Friday, respectively. But in any event, we're in class 7 of the a priori section and we finished Kant. Awesome. Kant is amazing, but we're through him. Now we're going to read John Stuart Mill. Let me hit pause on the recording and say something about John Stuart Mill. Okay, we're back on. All right, so let's see what he has to say about mathematics and experience. Remember, we're talking about the a priori certainty, knowledge before experience, that type of thing. Okay, here we go. If, as laid down in the two preceding chapters, the foundation of all sciences, even deductive and demonstrative sciences, is induction, if every step in the ratiocinations, even of geometry, is an act of induction, and if a train of reasoning is but bringing many inductions to bear upon the same subject of inquiry and drawing a case within one induction by means of another, wherein lies the peculiar certainty always ascribed to the sciences which are entirely or almost entirely deductive. Why are they called the exact sciences? Why are mathematical certainty and the evidence of demonstration common phrases to express the very highest degree of assurance attainable by reason? Why are mathematics, by almost all philosophers and by some, even those branches of natural philosophy which, through the medium of mathematics, have been converted into deductive sciences, considered to be independent of the evidence of experience and observation and characterized as systems of necessary truth? I don't know why I was about to hit pause. Okay, good. So we know what he was doing before. He was showing how induction plays a role in all of these things that he listed. And he says, but what about mathematics? Why do we call it the certain science? Why is it the sort of thing that we feel like we have a higher quality of knowledge about it, like mathematical certainty, necessary truth, things like that? Let me hit pause. The alleged necessity of the propositions of geometry is illusory. So he's going to say the necessity of geometrical that these are not necessarily true. Remember, Kant and other people we were reading were like, "Well, this is like necessarily true. This is deductive. This is 100% the case that the triangle has to have 180 degrees in the internal angle sum or something like that." Mill is going to say no, 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 no. Everything's really inductive. Maybe is what he's getting at. Let's see. The answer I conceive to be that this character of necessity ascribed to the truths of mathematics, and even with some reservations to be hereafter made, the peculiar certainty attributed to them is an illusion, in order to sustain which it is necessary to suppose that those truths relate to and express the properties of purely imaginary objects. It is acknowledged that the conclusions of geometry are deduced, partly at least, from the so-called definitions, and that those definitions are assumed to be correct representations, as far as they go, of the objects with which geometry is conversant. Now, we have pointed out that from a definition as such, no proposition, unless it be one concerning the meaning of a word, can ever follow. Remember, this is all about a priori, right? The meaning of a word. Is this all just analytic? And that what apparently follows from a deduction follows in reality from an implied assumption that there exists a real thing conformable thereto. Interesting. Okay. This assumption is the case of the definitions of geometry. It's not strictly true. There exist no real things exactly conformable to the definitions. There exist no points without magnitude, no lines without breadth, nor perfectly straight lines, no circles with all their radii exactly equal, nor squares with all their angles perfectly right. It will perhaps be said that the assumption does not extend to the actual, but only to the possible existence of such things. I answer that, according to any test we have of possibility, they are not even possible. Their existence, so far as they can form any judgment, would seem to be inconsistent with the physical constitution of our planet, at least, if not of the universe. Interesting. The way he's thinking is interesting. We'll talk about it. It's especially interesting. Well, it's interesting at the time he wrote it. I mean, it's interesting now, but it's interesting that he was thinking this way. Okay. To get rid of this difficulty and at the same time to save the credit of the supposed system of necessary truth, it is customary to say that the points, lines, circles, and squares, which are the subject of geometry, exist in our conceptions merely and are part of our minds, which minds, by working on their own materials, construct an a priori science, the evidence of which is purely mental and has nothing whatever to do with outward experience. By howsoever high authorities this doctrine may have been sanctioned, it appears to me psychologically incorrect. The points, lines, circles, and squares which anyone has in his mind are, I apprehend, simply copies of the points, lines, squares, circles which he has known in his experience. Our idea of a point I apprehend to be simply our idea of the minimum visible. This is an interesting psychological point. I'm not saying he's correct, but it's also interesting that he's doing this psychologically. The smallest portion of surface which we can see. A line, as defined by geometers, is wholly inconceivable. We can reason about a line as if it had no breadth, because we have a power, which is the foundation of all the control we can exercise over the operations of our minds. The power, when a perception is present to our senses or a conception to our intellects, of attending to a part only of that perception or conception instead of the whole. But we cannot conceive a line without breadth. We can form no mental picture of such a line. All the lines which we have in our minds are lines possessing breadth. If anyone doubts this, we may refer him to his own experience. I much question if anyone who fancies that he can conceive what is called a mathematical line thinks so from the evidence of his consciousness. I suspect it is rather because he supposes that, unless such a conception were possible, mathematics could not exist as a science, a supposition which there will be no difficulty in showing to be entirely groundless. We're starting to pick up on the themes here that really apply to this conversation, aren't we? Um, Ideas that are a priori truths. Are they necessary? Are they really truths? Are they really deductive? Is it an illusion? If so, are the truths about a priori things merely analytic? Right? He's going down that road, maybe setting the stage for the logical positivist to make that assertion, or maybe he just gets there on his own. We'll see. Um, And now look at what he's doing with the geometry arguments, right? Socrates comes in and he says, "Hey, look, you can know something and you can know something about something that's different than anything you've ever experienced. And that proves that there's this other world and all of this other stuff." And Mill is saying, "Oh, I'll just turn that upside down. Let me just take the axe to the root of that." You don't even have the ability to imagine the thing. You don't actually have that idea in your mind, Socrates. You don't have an idea of something other than notions you got from experience. What you did is you used the power, the faculty of your thinking to focus on one aspect of a perception at the exclusion of the others. And that led you to, you limited what you were really thinking about, and now you've got an idea that's unlike anything in the world, but that doesn't mean that it exists outside the world and you experienced it. It means that you did the opposite. You took the more real things and you reduced them until they didn't have certain boundaries, and then you called it the infinite, right? It's a complete inversion of that other way of doing it. And it's also like Hume, it's one of these guys on the other side of that who's saying, look, I can offer a psychological explanation for why it is that you think you have those notions when you really don't. Okay. Since then, neither in nature nor in the human mind do there exist any objects exactly corresponding to the definitions of geometry, while yet that science cannot be supposed to be conversant. about non-entities, nothing remains but to consider geometry as conversant with such lines, angles, and figures as really exist. And the definitions, as they are called, must be regarded as some of our first and most obvious generalizations regarding or concerning those natural objects. The correctness of those generalizations as generalizations is without a flaw. The equality of all the radii of a circle is true of all circles, so far as it is true of any one, but it is not exactly true of any circle. It is only nearly true, so nearly that no error of any importance in practice will be incurred by feigning it to be exactly true. When we have occasion to extend these inductions or their consequences to cases in which the error would be applicable or it would be appreciable to lines of perceptible breadth or thickness, parallels which deviate sensibly from equidistance and the like, we correct our conclusions by combining with them a fresh set of propositions relating to the aberration, just as we also take in propositions relating to the physical or chemical properties of the material if those properties happen to introduce any modification into the result, which they easily may, even with respect to figure and magnitude, as in the case, for instance, of expansion by heat. Let's pause. I've there's a few philosophers we're reading now that have 18 little parenthetical statements in every goddamn sentence. So let's just repeat. Now, I'm conscious of the fact I may not have read it clearly enough because of all those parentheticals to stick to what he's saying. So let's just paraphrase and repeat back what he meant by those last two sentences. It's really quite interesting. Excuse me. Let's do it in comparison with the Socrates thing again. Socrates, you're talking about a circle, an ideal circle. And he says, yeah, there's no such thing in reality. In the particulars, they're all approximations. Mill and I would agree. Imagine they're in the same room. Mill and I agree. All these circles are not really circles. Why? Because we know what a real circle is. And a real circle is something that these things are approximating. And Mill says, okay, well, let me explain how you got to your notion of a real circle, an ideal circle, that kind of thing. You looked at let's superimpose a thousand circles of the same basic size, a unit one radius circle, and we'll just sort of put them over each other so that we can kind of see the little blurriness of the edges when one happens to have a little bump over here and one a little bump over here. No, they're all approximate. None of them are perfect because they're in reality. And in reality, there's no such thing as a series of points that have no length, breadth, and width that are equidistant from a single point. Like that's not exact. Well, Plato's going to say, of course, that's in reality. It's more real than all these stupid approximations. But let's just stick with Mill for a minute. Okay, like, there's nothing I can pick up that's like that. Everything is, an approximation of that thing, and some of them are better, and some of them are worse. He's saying, so look, just notice that in general, what it's all aiming at is something that would be perfect, like that idea you have. So Socrates says, well, okay, the only way I know that is that I have that idea and I can see how they're getting close to it, right? This one's a really badly drawn one. It's got a real imperfection over on this side. This one's as close to perfect as you can imagine, but it's of course not. We'll zoom in on it and put a microscope on it, and it's a very jaggedy edge and all of this stuff. Okay, so what Mill says is, okay, you're noticing that the imperfections are random, they're not a pattern. So you're allowing all of the different imperfections to just cancel each other out, and you're just left with this notion of the thing they're all approximating. Not because you had that idea first in the afterlife or something, just because you're noticing that it's generally true of all of them, except where it's not, but it should be, and where it's not in each one is different than where it's not with the other ones. And then he says the only other thing to do is to say, no, wait a minute, this is not a circle anymore. This one here is really not a circle. It's got this real big aberration. So we're going to call it something else. And we're going to deal with it differently. Why? For the same reason. We noticed it isn't following that rule well enough to even be called a circle. So we'll develop other principles about, the mumpy circle or the the singularly imperfect circle, or whatever. We come up with terms. I think the Earth is not a sphere according to scientists, right? It's an oblong spheroid or something, right? So we'll call it something else, and we'll figure out what's true about that type of shape if we want to, or whatever. All right. And then he says, just like we do with physical things, right? So I say, okay, objects have a certain volume. That's one of their properties. And they have a certain temperature. That's another one of their properties. But then I notice that when I heat up the object, its volume also changes. And so I figure out the relationship between those things. I say, okay, wait a minute. It's not just that you get its volume by length, breadth, and width. You have to also look for maybe a specific heat for the type of material, and then also know its temperature. And then you can, something like that. He says, um, just like that. So what is he doing here? He's taking particular things and inductive science, and he's saying, I'm just gonna pull that geometry thing nicely over here and lodge it with the rest of these. We're really doing the same thing over with that. It's inductive. It's not it's not absolute or certain or anything like that, like we used to say. And whatever truths are certain, they're just analytic. They're just, it's true that all bachelors are unmarried men. Maybe there's a truth about the idea of a square that is like that, but that's not really knowledge that we're gaining. That's it's just analytic. Okay. I think this is where we left off. But it is an error to suppose, because we resolve to confine our attention to a certain number of the properties of an object, that we therefore conceive or have an idea of the object denuded of its other properties. We are thinking at the time, this is again a psychological point. Just because we can think of an aspect of the object doesn't mean that it's true that we can imagine an object with only that aspect. He's directly kicking Socrates in the shins. Okay. We are thinking all the time of precisely such objects as we have seen and touched, with all the properties which naturally belong to them. But for scientific convenience, we feign them to be divested of all properties except those which are material to the purpose, and in regard to which we deign to consider them. The peculiar accuracy supposed to be characteristic of the first principles of geometry thus appears to be fictitious. The assertions on which the reasonings of the science are founded do not, any more than in other sciences, exactly correspond with the fact, but we suppose that they do so for the sake of tracing the consequences without which follow from the supposition. The opinion of Dugald Stewart respecting the foundations of geometry is, I conceive, substantially correct, that it is built on hypotheses, that it owes to this alone the peculiar certainty supposed to distinguish it, and that in any science whatever, any way of knowing, whatever, by reasoning from a set of hypotheses, we may obtain a body of conclusions as certain as those in geometry. That is, as strictly in accordance with the hypotheses and as irresistibly compelling assent and as irresistibly compelling consent, on condition that those hypotheses are true. Everything's deductive. This is interesting because it has a double-edged sword here. It's kind of cool. He's saying geometry is not deductive. It's not absolute. It's not a syllogism that has to follow. What it is inductive, but the solidness of the conclusions, the quality of that still holds. You can still really, really understand, like, it's like almost necessary, right? Like two lines which are not parallel will cross at one point. So long as they're really lines, so long as they're really not parallel, so long as they never diverge from their direction, so long as they're straight. I mean, there's no such thing as that. So Mill is saying we're inducing, but when I talk about a line, I'm saying all. So let's actually do what he says we're doing really quickly, and we'll do it explicitly. Okay, I want to learn geometry. We're gonna. we're going to finish all this core material, but when I come back again to add other classes, we've got Euclid over here, and we're going to have a lot of fun with Aristotelian logic and geometry. That's a long way in the future because I want to do this core stuff first. But um, okay, let's do this. Let's say I want to know about geometry. Well, what do I really want to know? Well, I want to know that when I'm trying to build a house and I take a straight board, it's not really straight, you could really look at it and see they're bendy all over the place, right? And if I zoomed in, there's nothing like straight. But I'm going to take a straight board. It's approximately straight. For my purposes, it's straight. And I'm going to draw a straight line, which is not really straight on my blueprints because there's no such thing as a straight line that's perfectly straight. We're talking about ideal things, right? And what am I doing? Well, I'm saying, okay, I learned from Euclid that a straight line is going to cross another straight line at one point, and there's an angle between them, and I can figure out how long this other one has to be if it goes, whatever, if it's perpendicular to this first line, and I can do my measurements and make my plans. But the lines I'm using are not really ideal straight lines, and the boards I'm going to cut and nail together are not really ideal straight lines. But what I'm doing is I'm saying all boards are approximately straight lines. No, you know what I'm really doing? Because Socrates would say, no, there is a straight line and they're all approximations of it. What I'm doing is I'm saying, let's stop thinking about the rest of the board and let's only think about its edge. And Mill says, yeah, but there's no such thing as just the edge of a board. Right? You can't say, "Hand me the edge of the board, but leave the rest of it over there." What are you even asking? Are you even thinking about something? No. He says, so what we're doing is we're doing an inductive process, not a deductive process, and we're using a faculty of our thinking to focus only on one aspect of the thing, and it's an approximation and it's inductive. But we can use mathematics and geometry to make a good building, a good blueprint, a good design, and build a good structure. Why? Because all of the things involve approximate straight lines and all of them actually maybe that's a Socratic way of saying it, a Platonic way of saying it. All of them involve boards which I could ignore the length and breadth of, or the width and breadth of, and I can just think of the one side and right. So so if I just so there's 3 realms now. There's the mathematical idea of, okay, this line is coming off at a 35-degree angle from this line, and I need a line perpendicular at 90 degrees from this one, and this is 22 feet apart. Where will they meet? How long should this board be? Right? Well, that's over here when I'm cutting it. It's over here when I'm drawing it, and it's over here when I'm thinking about it in terms of geometry. Socrates says, yeah, in geometry, the ideal, the realm of the pure forms, says Plato. We'll say Plato, actually. The realm of the pure forms and all of that, the most real things, these are our shadows and approximations of that. It's very different. There's certain knowledge, perhaps, if only you could obtain it. And what Mill is saying is, no, that is really just this. Even the drawings themselves are kind of an abstraction from dealing with actual boards, and actual boards have edges, and I can think about just the edge of the board. And when I'm thinking about I can't really think of an object that's just the edge of the board, but I can restrict what I'm considering about the board to just its edge, and that gives me a line, and then I can go and draw a line that would be similar to that on my drawing, and then I can go a little bit more abstract and just think about lines and how they relate to each other. Okay, so what this means, though, is that the seeming certainty of the geometry stuff is still with us. But if we rightly, says Mill, I'm not agreeing with this, by the way, but if we rightly understand mathematics to be inductive, that's great news for us because our sciences are all inductive, as we showed before. So we could have really good certainty in science of things, like mathematical levels of certainty or convincingness. I like the phrase he used, irresistibly compelling assent, right? It's like the nature of deductive arguments is if you understand the argument, you have to believe the conclusion. You can't even stop yourself from believing it. That's how sure it is, right? Inductive, it's like, well, there's always more data to collect, right? We looked up one day, I think they used the example of all crows are black in one of our other essays. It's like, "Well, how do you know?" "Well, I collected 10,000 crows and they were all black, and so I figure all crows are black." Did you says your fellow scientist, your peer who's criticizing you, "Did you collect all those crows in your native country? Maybe, all the crows in your native country are black. Perhaps in every other country in the world, they're white or green or something. You don't know." "Okay, so we had scientists around the world collect 1,000 crows randomly as they could each, and they've all reported back that every single one of them is black." "Okay, well, we can be really confident that all crows are black." I know that there's some species that have albinism, like albino members of their species. Are crows susceptible to that? Could that be a white crow? And we'll have to look into it. Do they have genes that would allow them to blah blah blah, right? So you never really know certainly anything like that, right? Oh, we've looked at all the crows on planet Earth. We've understood what causes things to not be black. We've looked at the genetic code of crows and figured out that it's impossible for them to have that type of thing and still be a crow. All crows are black. Well, all crows that evolved on Earth are black, that use this basic DNA structure. But we went to Mars and we discovered that all crows on Mars are red. And it's like we're never really 1000%, 100% sure, right? That's the nature, it seems, of inductive arguments in science. But in this deductive reasoning thing of mathematics, it's like, no, no, no. If you understand what I'm saying and you agree with the premises, you believe the conclusion. Once I show you the lot, it's not, I don't have to try to get you to believe the conclusion. If you recognize the argument, it lives in your brain. It's impossible not to notice. I'm just showing you what must be the case. That's how strong deductive arguments are. And Mill is saying even mathematics is inductive. But he's saying at the same time, good news. There is a really cool level of certainty over there with that mathematics stuff, and it's also inductive. So our sciences could strive to be that good. We could be so careful in the definitions of the things that we're considering inside different fields that we could have like geometric levels of compulsive conclusions that like you just have to accept if we would do our science well enough because it's of the same nature. So anyway, that's what he's pointing out. Okay, or that's what he thinks is the case. When therefore it is affirmed that the conclusions of geometry are necessary truths, the necessity consists in reality only in this, that they correctly follow from the suppositions from which they are deduced. Those suppositions are so far from being necessary that they are not even true. They purportedly depart more or less widely from the truth. What truths, what things are not true? Lines. He's saying the definition of a line is a lie. He says it's not a truth because there's nothing in the world that is like that. One might wonder whether the pragmatists would really rejoice at that idea or maybe not like it for some reason, right? He's saying he's saying we've got such great certainty over here in geometry, but all of the basic terms they're using to start out are not talking about anything real. So they're not really truths, are they? They're basically, let's translate a sentence. Two straight lines that are not parallel will cross at one point. For Mill, what that means is if I have two boards and they're crisscross in some manner, there's only one point where I could put a screw in that would actually make them connect to each other. One small area of their overlap of their area or whatever. But I know that because I could say, well, each one has an edge and each edge is approximately straight more or less, and that the things that are like that do this. But wait a minute, there are no things that are like that, except that a lot of things are like that, but there's nothing that's just a line. The term line doesn't actually refer to anything, so it's not really true. How can it be true for Mill? Right, for Plato it's true because that's more true than anything real or anything. I think the French word for real has to do with substance, like material. So real is a good word for it. But anything substantial. All right. When therefore it is affirmed that the conclusions of geometry are necessary, blah blah blah. The only sense in which necessity can be ascribed to the conclusions of any scientific investigation is that of legitimately following from one assumption which, by the conclusions of the inquiry, is not to be questioned. In this relation, of course, The derivative truths of every deductive science must stand to the inductions or assumptions on which the science is founded, and which, whether true or untrue, certain or doubtful in themselves, are always supposed certain for the purposes of the particular science. And then he goes on. I'm gonna hit pause real quickly. So this is really interesting, and I think from a philosophy of science perspective, if we forget the geometry part for just a second, obviously everything the scientists say and their conclusions are all based on sort of the ideas they have to assume are true in order to start their questions and the concepts that they have to use in order to pursue their understanding. So when a biologist, maybe 50 years ago says, you are, or let's say, wow, 90 years ago, it's getting old. We're all getting old. When a biologist 90 years ago says you are nothing but the expression of your genes, we've heard people say that in the 90s, of course, but um, when they say that, like, what do they mean? Right? You're not, first of all, a philosopher could say, no, you're not. Your genes are orders of magnitude less complicated than the number of connections of the neurons of your brain that they code to make possible to exist, perhaps. The words that you're choosing to use in a sentence are not coded into your genes, and that's a part of what you are and who you are. And so, of course, that's not true. But but why are these scientists saying it? Why are they saying things like that that are not true? It's because they have to start thinking that way in order to answer all the questions they can answer within the field of biology, right? That's their field. And science is very much like Mill is talking about with the geometry. It's saying, like, let's limit our considerations. I don't know if I've shared this before in one of our classes, but I'm going to share it now because it's really a very valuable joke. And in philosophy, there's a lot of jokes and there's a lot of thought experiments that are useful. And Mill is very good on science, by the way. I mean, we saw in the determinism free will section, he's very, very clear about like the notions we have and what it is we're doing scientifically. I think it's quite valuable, his insights there. But okay, a team of oil sheiks from Saudi Arabia get together and they pool a bunch of money and they hire the best physicists that they can find. They just call them to a meeting, actually, and they hire the best statisticians they can find, and they hire the best biologists. They pull them all into a meeting, and they say, "Okay, you guys are the teams of the best, of the best, of the best. And here's what we want you to do. We want you to use your particular sciences and develop for us a system for predicting the winner of any horse race. Get on it. Everybody's betting on horse races. We want to make a lot of money. So if you can tell us who the winner of the horse race is going to be ahead of time, use your biology, use your statistics, use your physics, whatever you got to do, develop a system that will tell us ahead of time who's likely to win the race and come back in 8 weeks, 18 weeks with your proposal of how good the system is and we'll pick among you and we'll buy one of these systems. Okay. So they all go away. 18 weeks later, they come back. The statisticians step forward and they say, hey guys, we got some exciting news. It's going to blow your mind. Um, Instead of running away and using this system to become billionaires, we thought we'd come back and tell you for some reason, but we've got a system for you. And it will accurately tell you the winner of any horse race 60% of the time. 60% of the time, it will get it right. Okay. That's pretty damn good, right? 60% of the time, it's a 1 in 6 chance. You guys are going to be making a lot of money off of that. And, it involves some supercomputers. It involves a lot of math. There's going to be a big upfront cost to get this going, but we're highly confident that when the system is fully done, it'll work at well, 59 to 60. We've got some disputes still, but somewhere around there, it's going to tell you the winner of any horse race. It'll be right about that often. And the sheiks look at each other like, this is a good idea, brother. Heck yeah. So they say, okay, cool. And the biologists come forward and they say, oh, so he says, "Well, how much will it cost?" I go, It's about a $10 million investment, right? Well, that's a good deal, right? $10 million investment, but hey, we're gonna get that back in no time when we're betting on these horse races. So, okay. All right, thank you very much. The biologist stepped forward. All right, what did you figure out? This is crazy. You're not gonna believe this, but did I say $10 billion? For $1 billion or 10 million, $1 million, we've got a system for you. It's going to accurately tell you a week before the race which horse is going to win 80% of the time. 80% of the time it works and it only costs $1 million. Everybody's like, whoa, this is exciting. We're going to make a lot of money here. That's awesome. I say, okay, the physicists come forward. All right, what do you got? Oh, we've got, look, we're physicists. We are the real science. Right? Everybody else is stamp collecting. We're the physicists. We developed a system. It'll cost you about $100 and it'll give you the correct answer for the winner of a horse race 100% of the time. That's what we've come up with. They look at each other like, "What?" Yeah, we sat, we never thought about this problem before, but we had 18 weeks to think about it. We figured it out. You take the names of the horses, a few factors about the horses, put them in here. The formula works itself out. Here's the winner of the horse race 100% of the time. Costs $100. Just give me $100. I'll go get a meal. That's enough. I'm gonna fly home. And they're like, here's $100. I don't have a bill that small. Will you take 1,000? Give us the system. All right, here's the system. Get your pen and paper. Okay. First, model the horses as an ideal sphere and ignore wind resistance, right? It's like okay, you get it's a funny joke. Okay, so imagine a horse as an ideal sphere. This is, so what the science is doing is it's restricting what it's going to be considering in order to allow itself to make progress within that. And of course, the progress is really valuable, but there is an element of that happening. I should hire a comedian to tell jokes, but that's a fun joke. In any event, Mill is pointing out that even in these deductive sciences, or no, that in these sciences that are more inductive, it's all dependent upon the terms that you use to start with. You start with those terms, you limit what it is you're going to consider, and then you figure out what the conclusions are. He says, well, we're doing the same thing with geometry. We're starting with some notions that are approximations of partial considerations of certain aspects of things that we perceive. Okay. If that's true, it works. And if it's not true, which it isn't really, when it's not true, there will be problems in the science, right? What would be an example? Let's go back to boards and straight lines. Um, if you need the boards to be straighter than they are to work, let's say you're building with materials, um, something that's going to be sent to Mars. Maybe the lines need to be a bit straighter and the edges need to be a bit straighter than when you're building a house on Earth. So, hey, wood is a great thing to build with. Yeah, not if you need straight edges. What do you mean? We got straight edges. We're living with straight, not really. You're living with crooked edges all over the place. But if you need them to be really straight because they've got to dock with the space station perfectly, you might need a different material. But it doesn't become clear that the board isn't really straight if the approximation of it being straight is good enough for the purposes that you're using it. All right? That's what he's pointing out. And so the geometry as applied to the structure of a house works with wooden boards because even though it's not true, not just of the board, but the notion of the line as applicable to the board, as what you get when you consider only the edge of the board, it's not true. That's not actually what the edge of a board is like. But you're using that concept, and he says you're deriving the concept from just considering the edge of the board. But that's not true. The edge of the board is not straight line. And furthermore, you can't just think about just the edge of the board without the rest of the board. It's just you're only considering one aspect of the board. But you couldn't imagine handing someone the edge of a board but leaving the rest of the board. So he says we're starting with these it's all inductive. We're approximating, we're limiting what we're considering about the board, and then from that we're coming to other conclusions. He says, wow, in geometry, if you take lines and their angles, you can really, this is what people talk about mathematical certainty. You know for sure there is one point where two lines cross that when they're not parallel, and only one. You couldn't be more sure of something than that. He goes, yeah, that's really, really certain. Except, what's this line you're talking about? Every time you apply the idea to something, you're really getting the idea of the line from only considering one aspect of that thing, and it's not really like that at all. It works as an approximation for now until you get to an area where it doesn't work, and then you come up with a better theory and a new way of doing things, a new machine for making a straighter edged material or a synthetic fiber material that has a straighter edge or something like that. Okay. The axioms are experimental truth. What is the ground of our belief in axioms? What is the evidence on which they rest? I answer, they are experimental truths, generalizations from observation. The proposition two straight lines cannot enclose a space, or in other words, two straight lines which have once met do not meet again, but continue to diverge, is an induction from the evidence of our senses. Ooh. So he's not just saying we got the idea of the line, he's saying the properties of the line we're getting from the fact that the approximations of the idea of the line from which we got the notion tend to work out that way. I'm going to keep sticking with explaining what he's saying. I'm not saying I'm convinced by this or that I think it's true. It might be true. I mean, it might just be unwelcome to me and it might be very true. So I'm not saying it's not true either. We're just going to, for now, we're just going to stick to understanding what he's talking about and we can quarrel about it later. Um, the properties in geometry are gotten from induction of the things that we imagined we used to derive the notions. Interesting. Let's read that sentence again. The proposition two straight lines cannot enclose a space, or in other words, two straight lines which have met only once will only meet once and never again, but continue to diverge, is an induction from the evidence of our senses. I imagine an infinite black space, and I imagine the illumination of the concept of a series of points that are all in a straight line. And in this space imagined by me, there's this straight line and there's this other straight line, and that the two are going to cross in a plane. They're going to cross each other once. And as I keep looking, I see that the further I go on each line, the farther away the two lines get from one another. And I realize that that will continue indefinitely because of the process of them getting further, as straightness continues, divergence necessarily continues as well. And I see all that in my mind. And Mill is saying, no, you don't. What you did was you've played with blocks as a child and you played with Lincoln logs and you called them straight when they weren't. And you understood that the curvy connector was different than the straight connector. And you tried building things out of wood and you built a skate ramp in your backyard. I just remembered that I did that once. I built a half pipe. It was very flimsy. I was a ridiculous child. Okay, so you built things out of wood in your yard. And you notice that the further longer away, like this notion of straightness was something that you obtained from partial consideration of the things you were working with. And that's how you came to understand because now in your black space of imagination with the mass or the volumeless points extending out, you're just taking one aspect of that and focusing on just that and thinking about just that, but really you got that from experience. Okay, I have some questions, I'm not sure, but okay. We just want to understand where Mill is coming from and what he's saying. And he's very insightful sometimes, and he's obviously right about certain things, I think. So let's I'm going to try to wrap my head around this way of thinking. This opinion runs counter to a scientific prejudice of long standing and great strength, and there is probably no proposition enunciated in this work for which a more unfavorable reception is to be expected. So, great. He's hypnotically recognizing that I'm having trouble swallowing what he just said. It is, however, no new opinion, and even if it were so, would be entitled to be judged not by its novelty, but by the strength of the arguments by which it can be supported. I consider, fair enough, man, let's hear it. I consider it very fortunate that so eminent a champion of the contrary opinion as Dr. Wewell has found occasion for a most elaborate treatment of the whole theory of axioms as attempting to construct the philosophy of the mathematical and physical sciences on the basis of the doctrine against which I now contend. Oh, by the way, I just came up with an imaginative way of understanding that axiom, but an axiom shouldn't be derived by anything. There's like five axioms or whatever from Euclid, isn't that right? So maybe I'm blaspheming every way of thinking about this, but let's go. Whoever is anxious that a discussion should go on to the bottom of the subject must rejoice to see the opposite side of the question worthily represented. If what is said by Dr. Wewell in support of an opinion which he has made the foundation of a systematic work can be shown not to be conclusive, enough will have been done without going elsewhere in quest of stronger arguments and a more powerful adversary. So he's saying Dr. Wellwell made a really great case against what I'm saying right here. All I have to do is show that it's not certain that he's right, right? If it's not definitely true what he's saying, that's all I need to do to say to leave some space open. So and look, no one's going to come up with a better argument than his. So let's just deal with his and see what happens. It is not necessary to show that the truths which we call axioms are originally suggested by observation and that we should never have known that two straight lines cannot enclose a space if we had never seen a straight line, thus much being admitted by Dr. Wellwell and by all in recent times who have taken this his view on the subject. But they contend that it is not experience which proves the axiom, but that its truth is perceived a priori by the constitution of the mind itself. From the first moment when the meaning of the proposition is apprehended, and without any necessity for verifying it by repeating trials, as is requisite in the case of truths really assented or as ascertained by observation. Here's the nature of the debate as he's setting it up. Everybody on both sides agrees that you don't really have the word straight line to use until you've been experiencing things in the world and grown up. That's fine. The opposition to Mill agrees with that. But the question at issue here is, can you prove that two straight lines that intersect at one point will never intersect at another point? Can you prove that and come to know that truth by induction, as Mill says, from experience, or prior to experience? All right. So maybe you need experience to have the terms, but just understanding what the terms mean. Like I was trying to say, I think my brain works this way, and maybe it's an imagination after the fact, a just so story that my brain is telling me. Just because I'm telling you that this is how I'm thinking about it doesn't mean that that's correct. Maybe, you know, so for Dr. Wellwell, it might be something more like what I was describing. Like I can think about the necessary consequences of adding to straightness and of divergence as a concept and the necessity that these things are going to get further and further apart forever. They're never going to touch therefore again, right? I think I can get that without doing an experiment, without going and investigating a priori. Mill is going to say, okay, good argument. Let's focus here. Can you know that a priori? They cannot, however, he says, but allow that the truth of the axiom two straight lines cannot enclose a space, even if evident, independent, independently of experience, is also evident from experience, whether the axiom needs confirmation or not. It receives confirmation in almost every instant of our lives, since we cannot look at any two straight lines without which intersect one another without seeing that from that point they continue to diverge more and more. experimental proof crowds in upon us in such endless profusion, and without one instance in which there can be even a suspicion of an exception to the rule, that we should soon have stronger ground for believing the axiom, even as an experimental truth, than we have for almost any of the general truths which we confessedly learn from the evidence of our senses, independently of a priori evidence. We should certainly believe it with an intensity of conviction far greater than we accord to any ordinary physical truth. And this, too, at a time of life much earlier than that from which we date almost any part of our acquired knowledge, and much too early to admit of our retaining any recollection of the history of our intellectual operations of that period. Oh my gosh, Mill is a psychologist. He is going to be judging his opponents psychologically. He's gonna be judging the question at issue psychologically. This is powerful. His argument's pretty strong. I don't like it, but it's a strong argument. He says, "Okay, look it. You think that you can get this conclusion about the straightness of the widthless lines and all this, and it's from concepts and necessity and deduction and all of that. You think so. But how do you know that's how you got it? That picture in your head, could that picture in your head be an approximation of every single time you've ever encountered 2 straightish things that crossed each other? How do you know? How do you know that that impression in your mind, that thing you think you're deducing and creating in your brain, isn't immediately derived from experience? Because you've had a lot of experience with intersecting straight things before. And maybe all the times you saw this and everything in that category, you just sort of superimposed them all on each other, and abstractly, you've just got this idea, oh, they keep getting further away from each other. And then you think that you're deriving that and figuring it out just intellectually before experience, but you've been data collecting from experience that exact thing since before you were old enough to remember you were doing it. And your report of what you felt back then means nothing because you don't even have memories of what you were thinking back then. That's pretty good, right? He actually says one other thing here too, which is also pretty good. Well, I think I included them both, but we'll emphasize the other one again. How do you know it's not from experience? You've been experiencing this for a long damn time. Let's bring Socrates back in the room. You think you died and were born and resurrected? Oh, no, not resurrected. You were reincarnated again, and in the afterlife, you're at one with the forms, Plato says. Let's say Plato. And that you've experienced directly true straightness and true equality and true sameness and true circleness and all of this stuff. And then you get incorporated into a body, and now you go around saying, whoa, nothing's truly any of those things. How do you know? Because I must have experienced it some other time. I'm not experiencing it now, but I can use those notions to make sense of those things. Okay. Mill says, or when you experience a rectangle, a two by four, it has length, it has breadth, it has width. You could consider just the length and not think about the other things. You do that all the time. You might call that a line. It's not real. There is no just the length without the breadth and width and have a still a board, but you can just chop up your notion into just considering a few things, and you've been deriving them from experience in this world, not with the pure things somewhere else. Okay. Independently of a priori evidence, we should certainly believe it. Oh, yeah. And this is the other thing he says. He says, look, um, this amount of data that you've been collecting about the nature of straightish things that cross each other at a point, you've collected way more data for that than things that we are really sure are true in science because we've collected way less data than that. And yet we're really confident about it. That's how much data you've collected. Are you really sure you're not deriving these things from experience, says Mill? I think I can trace the psychological journey here. You gotta notice you have an intellectual faculty of approximately considering just certain aspects and all of that, but I think it's all from induction. Independently of a priori evidence, we should certainly believe it with an intensity of conviction far greater than we accord to any ordinary physical truth, and this too at a time of life which earlier than we can date and acquired knowledge, and much too early to admit of retaining any recollection of the history of the period. Blah 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 blah. Could have said that in 4 words, but okay. Where then is the necessity for assuming that our recognition of these truths has a different origin from the rest of our knowledge when its existence is perfectly accounted for by supposing its origin to be the same? When the causes which produce belief in all other instances exist in this instance, and in a degree of strength as much superior to what exists in other cases as the intensity of the belief itself is superior. I lost that sentence. I'm so sorry. Let me start it again. I got lost. Where then is the necessity for assuming that our recognition of these truths has a different origin from the rest of our knowledge when its existence is perfectly accounted for by supposing its origin to be the same, when the causes which produce belief in all other instances exist in this instance, and in a degree of strength as much superior to what exists in other cases as to the intensity of the belief itself is superior? He just repeated his argument from before with the example. Okay. The burden of proof lies on the advocate of the contrary opinion. It is for them to point out some fact inconsistent with the supposition that this part of our knowledge of nature is derived from the same sources as every other part. Let's pause for a minute. There's a few things to say about, let's do a meta analysis here, real quickly, of Mill. Something really impressive and interesting about the whole project he's trying to do here, the psychological project of explaining maybe and explaining maybe our misunderstanding of how we thought there were ideal things, perhaps. I mean, not us, but addressing that aspect of philosophy. And then also the psychological methods of his arguments by how he's going forward, right? He's not really just telling a just so psychological story. He's making a case that sort of following how we come to know things inductively. Um it seems like he might have a commitment to that idea rather than really in other words, I sort of almost feel like I hear 2 people giving me a just so story at this point. You know what I mean? Like, here's the platonic just so story. I don't even just mean of the afterlife and all of that stuff. I just mean of the nature of the way we think about ideal things that are not like the rest of the world and how we come to our deductive conclusions. Okay, that could be a psychological just so story that you gave there, but also that's what I'm hearing with you too, which is I mean, I'm not really sure what the argument is here um for why it has to be the case. But of course, we're reading this after he says, "Oh, now that we've proven all this other stuff is inductive, let me show that this is too." So maybe he makes that case earlier. But it's a heck of a thing he's accomplishing here, or trying to accomplish at least. And I especially like this. I like this argument here. It's like, how do you know you've collected way more data in your experience from the time you were young about the nature of straight lines and some of their qualities in approximate form than anything we've collected in the rest of science, and we're pretty confident about some of those things. Are you sure you have certain deductive knowledge that you arrived at prior to experience? Or did you just have a boatload of experience from the time you were too early to really know you were collecting it? That's a cool idea. All right. Let's try to get through this. Although I have to say, this a priori stuff is heavy. I mean, Kant is heavy anyway, and we took 2 days to get through Kant. I think what we'll do is we'll cut this short halfway through and we'll do 2 days on Mill too. I'm sorry to do that. I mean, this is a really fun section, so I'm not sorry to do it. Uh, but following these arguments, for me specifically, I haven't focused a lot on this topic before, and following it carefully as we go through is necessary. So maybe we'll just stop halfway through, but let's finish this section. Okay. This, for instance, they would be able to do if they could prove chronologically that we had the conviction. Oh, so another objection one might make to this argument of Mills is that it might be a version of the genetic fallacy, right? Now, this is the whole issue at point, so maybe that doesn't work. But remember, the whole thing that we're arguing about is whether or not you can know some geometric deductive truths prior to experience. And even the people who think you can say, but to know what the meanings of the words that you're using in those deductive sentences, you would need experience. You'd have to grow up and you'd count blocks and you'd learn what straight line means. And I could define it afterwards and say, oh, it's really not anything you've ever encountered. It's a series of points that go on forever in both directions that are straight and don't curve and blah, blah, blah. Right. So we could define it that way. In fact, I think the definition, you ever hear the phrase, two points define a line? I used to think that meant give me 2 points and I'll just draw a straight line between them. But I think what it means is a line is all of the points that are the same distance from one point as they are from another point. So if you take 2 points, here's a point right in the middle. It's the same distance from this point as it is from this point. But if you go up here, this point here is the same distance from this point as it is from this point. So all of the points that are the same distance, each of those points to 2 other points are a line. So the 2 points that define the line, I don't think are actually on the line. But in any event, it doesn't matter. The point is, um, even the other side often agrees, like, well, okay, you have to know what point means, and to do that, you've got to, but Camille says, no, when you have point, what you're doing is you're saying, I see tiny little specks of dust, and I imagine the smallest one that would still be visible, and then I sort of imagine that, except I think it has no length, breadth, or width or something. But the picture in my head of the thing has length, breadth, or width or something, if I think I can picture it, right? My picture of a point isn't blank nothingness, right? It's like the location is denoted somehow, even in my brain, as like maybe there's a line and a line from like graph paper in the middle of the space, but like there's a location that's identifiable. So it's like what's this breadthless, widthless, lengthless point that you're talking about? Okay. Well, what it is the partial consideration of the location of the, let's say, the lowest, furthest to the east aspect of an object, right? So I've got an object, but I could take the point that is like, let's say it's a cube. I could take the point that is the like one of the corners of the cube. I could say that gives me a location for the cube. All right, but there is not that point. What there is the cube, says Mill, and then you're only considering less and less and less of the cube over to there, and that's where you get your notion of a point. Um, and then from the time before you even really could define properly any of these terms, you've been collecting evidence about how these things relate to each other, and that's where you're getting your axioms. So, um, the whole argument between these a priori knowledge people and a guy like Mill, who say if he's gonna say everything is inductive, it's induced from experience. Deductive things are logically necessary. They're, the words themselves, the ideas, the statements, if the premises are true, the conclusion must be. That's sort of the realm of deduction. But induction means I'm collecting and it's approximate and it's not 100%. But he said, well, geometry is pretty confident, but it's also of that nature. And our science could be that confident too if we did it properly, maybe. All right. The whole debate between these two is, can you know anything? Know anything? Can you add to your knowledge prior to experience? All right. And Mill thinks no, obviously. He thinks everything's inductive. This, for instance, they would be able to do if they could prove chronologically that we had the conviction, at least practically, so early in infancy as to be anterior to those impressions on the senses upon which, on the other theory, the conviction is founded. This, however, cannot be proved, the point being too far back within the reach of memory and too obscure for external observation. That's an interesting idea. Okay, so if Mill's argument so far is really strong, and maybe we think it is, maybe we don't, but imagine someone who wants to argue for a priori knowledge. They've been pushed back on their heels now. They've been knocked in the face by Mill saying, wait a minute, how do you know this is prior to experience since you've been collecting mountains of experience on all of this stuff for a really long time, so long that you don't even remember what you were thinking at the time you collected it? Um, and then he says, okay, if you want to prove me wrong, one way you could do that is discover something in the prenatal fetal mind, the fetus's mind, that has a notion of a point. If you can show me that, an innate idea, right? Remember, we used to say a priori people, they don't need to have an innate ideas, right? Those are two different ideas. You don't need to say I'm born with the idea. You could say, no, I could come to understand the meaning of the term and the idea through experience, but I can still get to the truth deductively about, lines and triangles and things like that. He says, no, you've been collecting evidence about approximate lines and triangles, and the line and triangle you're talking about is really a I don't know what the word we should use for this is. I don't want to stop saying approximation. I want to say it's a partial consideration of one aspect of all those approximately line-like things that you've been talking about and data collecting. So now if one of the he says one of the ways you could prove me wrong is you could discover innate ideas, but you can't remember that far back accurately. And I don't know what experiment you're gonna do to discover that a newborn child has an idea of what a square is and would be able to tell the difference between a square and a circle, or the idea of a point and a line, something. Do they have any of these innate ideas? Because I could agree that it might be prior to experience if they have that notion. I'm not sure they have that notion, though. I also don't know how you could prove it, but that's interesting, right? Why is it interesting? It's interesting because if we knew more about philosophy of mind, which I know is one of your special interests, if we knew something more about neurology, if we like mapping out a brain is a pretty complicated thing to do. I think they did it for like a really, really tiny, simple type of worm once. They actually made a computer model of all the neurological connections of this tiny, retarded little worm, but to do it for a human mind, I don't know if they've done that yet. Maybe they have. Things are expanding and growing pretty quickly, but seems highly unlikely. But if you could understand a lot more about the brain than we do, perhaps you could say these are innate structures for pointness and lineness that are built into you prior to experience. But he thinks that you'd have to go that far, or at least that's one way you could prove him wrong. That a stone thrown into water goes to the bottom may be perceived by our senses, but mere thinking of a stone thrown into water would never have led us to this conclusion. Not so, however, with the axioms relating to straight lines. If I could be made to conceive what a straight line is without having seen one, I should at once recognize that two such lines cannot enclose a space. Intuition is imaginary looking, but experience must be real looking. If we see a property of straight lines to be true by merely fancying ourselves to be looking at them, the ground of our belief cannot be the senses or experience. It must be something mental. Wait a minute. What? Oh, I got to the next paragraph. That's why. So he's giving another way that you could disprove it, but let's just see here. So early in infancy, this, however, cannot be proved. The point being too far back in memory and an external observation of the infant. The advocates of the a priori theory are obliged to have recourse to other arguments. There are reducible to these are reducible to two, which I shall endeavor to state as clearly and as forcibly as possible. So here's the next type of argument the a priori people might give to Mill. He says, in the first place, it is said to the assistant that if our assent to the proposition that two straight lines cannot enclose a space were derived from the senses, we could only be convinced of its truth by actual trial, that is, by seeing or feeling the straight lines, whereas in fact, it is seen to be true by merely thinking of them. That a stone thrown into water, blah, 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 da, 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 da. I could be made to consider. I should at once recognize that the two lines cannot enclose a space. Intuition is imaginary looking, but experience must be real looking. If we see a property of straight lines to be true by merely fancying ourselves to be looking at them, the ground of our belief cannot be the senses or experience. It must be something mental. To this argument, it might be added in the case of this particular axiom, for the assertion would not be true of all axioms, that the evidence of it from actual ocular inspection is not only unnecessary but unattainable. What says the axiom? Two straight lines cannot enclose a space. Then, having once intersected, if they are prolonged to infinity, they do not meet, but continue to diverge from one another. How can this, in any single case, be proved by actual observation? We may follow the lines to any distance we please, but we cannot follow them to infinity. For aught our senses can testify, they may, immediately beyond the furthest point to which we have traced them, begin to approach and at last meet. Unless, therefore, we had some other proof of the impossibility than observation affords us, we should have no ground for believing the axiom at all. So those are the two arguments against his position he thinks have some hope. Through these arguments, which I trust I cannot be accused of understanding, a satisfactory answer will, I conceive, be found if we advert to one of the characteristic properties of geometrical forms, their capacity of being painted in the imagination with a distinctness equal to reality. In other words, the exact resemblance of our ideas of forms to the sensations which suggest them. This in the first place enables us to make, at least with a little practice, mental pictures of all possible combinations of lines and angles which resemble the realities quite as well as any which we could make on paper. And in the next place, make those pictures just as fit subjects of geometrical experimentation as the realities themselves, inasmuch as pictures, if sufficiently accurate, exhibit, of course, all the properties which would be manifested by the realities at one given instant and on simple inspection. And in geometry, we are concerned only with such properties and not with that which pictures could not exhibit, the mutual actions of bodies one upon another. The foundations of geometry would therefore be laid in direct experience, even in the experiments, which in this case consist merely of attentive contemplation, were practiced solely upon what we call our ideas, that is, upon the diagrams in our minds, and not upon outward objects. For in all systems of experimentation, we take some objects to serve as representations of all which resemble them, and in the present case, the conditions which qualify a real object to be the representative of its class are completely fulfilled in an object existing only in our fancy. Without denying, therefore, the possibility of satisfying ourselves that two straight lines cannot enclose a space by merely thinking of straight lines without actually looking at them, I contend that we do not believe this truth on the ground that the imaginary intuition simply, but because we know that the imaginary lines exactly resemble real ones, and that we may conclude from them two real ones with quite as much certainty as we could conclude from one real line to another. The conclusion, therefore, is still an induction from observation. If you can't say something nice, don't say anything at all. Okay. This might be a stronger argument than I'm thinking it is right now. So let's move on. And we should not be authorized to substitute observation on the image in our minds for observation of the reality. If we had not learned by long continued experience that the properties of the reality are faithfully represented in the image, just as we should be scientifically warranted in describing an animal which we have never seen from a picture made of it with a daguerreotype, but not until we had learned by ample experience with observation of such a picture is precisely equivalent to observation of the original. Okay, so we're going to stop there. I'm not sure I fully understood this paragraph. I'm going to approximate what I think he's saying, and maybe we'll start next time by rereading this paragraph and seeing if I can understand it better by then. But I think one of the things he's getting at is the idea that the idea in our minds is actually something we're looking at. So it's still an image, And the only right we have to think of it as applying to the notions we have is that it applies to real things that are like the straight lines. So it's still inductive. That's all I got from it. So maybe I'm too tired to read this paragraph, or maybe I'm too stupid to understand it. Let's start again next week by rereading that paragraph, and then that ends that section, and we'll finish up with Mill, and we'll wrestle with him some more. Um, let's leave the recording running since none of this is live streaming, and we can have our conversation, and we can edit it out at some point before making it go live. So what can we do here? I know what I can do. I can do this as like a flash thing for where to cut it. Actually, I'll end it right now. We'll decide if we want to re-record and continue